right, you guys, let's do a quick overview of the correlation coefficient, okay? We're going to start just by looking at a scatter plot so you get an idea of what the correlation coefficient is. You will have two variables, and here we're talking about the height of buildings, and does that correlate with the number of stories? Okay, well, you make a scatter plot, and when you get the scatter plot, you could see what we're looking for is, could you put a line through there? It's called a line of best fit that would possibly be able to use for predictions. And the correlation coefficient tells you whether you have a positive, negative, a good relationship, a strong one, I should say, or one that's not so strong. The correlation coefficient helps us decide if we should continue and find the line of best fit. So we're going to figure out the correlation coefficient for this in a minute. I just wanted you to see that. Here's another one we're going to do, absences and final grades. Okay, so here's the number of absences, here's the final grades. Now you'll notice in the previous example, as the height went up, the stories went up. This is called a positive linear relationship. Whoops, sorry. I wrote all over that. Let me erase that and try again. It's called a positive linear relationship. So on the next one, what we're going to see as absences go up, grades go down. This is called a negative linear relationship. Now we are in elementary statistics, so we are only going to deal with linear relationships. Okay, that'll be the only kind we deal with. This one, could we get a line of best fit? I do feel like there's correlation between those two, so I expect there to be a really good correlation coefficient, but it will be negative. Okay, the correlation coefficient for the last one would be positive because as one goes up, the other goes up. For this one, it will be negative. As one goes up, the other goes down. The last one we're going to look at just quickly is there a correlation between average wind speed and maximum wind speed? Now you're probably thinking, I don't really think there's one. And when you use a scatter plot, you really don't see much of a correlation here because maybe it's negative, maybe it's positive. It's hard to tell where you would put your line. So our correlation coefficient is not going to be really good for this one. So on this one, the main thing you need to know is this down here. Do you have a strong relationship or one that's not so strong? Is it positive or is it negative? All of your correlation coefficients are going to be between -1 and +1. And what you are trying to get is some that are closer to +1 or closer to -1. What you don't want is one thing you can do is think of them as percentages. If my correlation coefficient is, let's say, 0.30, that would be in here. It's kind of the same thing as saying, okay, it's going to work 30% of the time. Even though it's not percentages, I realize that. It is a good way to help you learn it. Okay, 30% is not great. But if I have 90% or 80%, that's good. Now, a -90 or -80 is just as good, you guys. The fact that it's negative just means that as one goes up, the other goes down. But it is still a good correlation coefficient. Also, notice they don't give you numbers down here like what's the breakoff point, right? Is this 0.75? Is this 0.60? What is the breaking point there? That's because it really depends on your purpose. We've talked about that before in class. Maybe you're doing medical research and you need your correlation coefficient to be up here for you to consider it strong enough. But if you're doing other kinds of research, maybe you'll hit down here is okay. All right, so it just depends. That's why they don't give you a cutoff number. This is just examples of what would a 0.50 look like for a correlation coefficient, which is called R. This is a 0.90. This is a 1. This is a -0.50, -0.90, -1. The ones are almost impossible in real life, but this is the formula. It's also on the next page. We're going to color code this for you. So this is the formula for correlation coefficients. So what you're going to do, and we're going to do one example together. They're going to give you some X's. They're going to give you Y's, and you're going to make a chart, okay? And that chart is going to be used to fill in this formula. Let's look at it on the next slide. So here's what you need in your chart. X times Y, X squared and Y squared. So you are going to make a chart with 5 columns. Now what I want you to notice is in this formula, what we're going to do is we're going to add them up, and that's where the summation comes from. In this formula, the sum of the X column, you're going to put here and you're going to put here. Let's color code a little. The sum of the y column goes here and here. The sum of the x times y column, that means you take your x times your y, you write it down, then add them up. The sum of the xy column only goes here once you add that one up. Next, let's look at the x squared column. You take each x and square it, then add them up. Now, the x squared, sum of the x squared goes here. I want you to notice the difference here. This is the sum of the x's, then you square it. This is the sum of the x squared column. See the difference there? So be careful. And let's do this last one in orange. I'll probably get the colors wrong on the next page, but that's okay. I won't stick with the same colors. So the sum of the y squared column goes here. Notice this is the sum of the y's and then you square it. This is the sum of the y squared. Last thing I want to point out about this formula is n. N is always the number in our sample. Be careful though, because they're going to give you x's and y's and sometimes students add that up. So I always tell students to remember that n is the number of x values. Don't do x and y. Those come in pairs. Okay, it's just the number of x values. Okay, so let's look at an example. So this is back to the height of buildings. Here's my heights. I put them in a column. Here's my stories. I put them in a column. Notice we have 1, 2, 3, 4, 5, 6. So our n is going to equal 6 here. To get xy, I do 1,136 times 83. I get 94,288. I put it there. I do 887 times 76. I put it here. 756 times 50. Put it here. Add them all up. Okay, and then this column, x squared. So 1,136 squared, I put it here. 887 squared, I put it here. And so on. Add them all up. The y squared column, 83 squared goes here. 76 squared goes here. Add them all up. Now what we have in this bottom row, these are all our summations. Okay. Sorry, I'm not real good with the sigma symbol when I'm in a hurry. But these are going to be all of our summations that we are going to use to put in our formula. Now you'll notice on the next page I just copied the total row. So here's my totals. This is the sum of my x's written above. This is the sum of my y's, the sum of my x times y, the sum of my x squared, and the sum of my y squared. Okay, let's figure out where they go again. Sum of x's, you're going to write here and here. So my 4,543 goes here and it goes here. My sum of my y's, again, my colors are going to be different on this page, but that's okay. Sum of my y's is 351. So my sum of the y's goes here and here. So my 351 goes here and here in the formula. Next one, my sum of my x times y. That one goes here. So my 283,901 goes here. Let's do a couple more. Let's do my sum of my x squared. That goes right here. So that number goes here in the formula. And my last one is my sum of my y squared. And my sum of my y squared, my teal color, goes here. Okay. Now, the next thing we want to do is plug it all in. This is the answer we're going to get. I am going to tell you, after teaching this many years, okay, you guys know how long I've been at this, you can try one time plugging that whole thing in a calculator and see if it works. If it doesn't work for you the first time, please do not do that on a test. You're going to spend forever, and when you're on a test, you're not going to realize you're missing it, okay? Also, while I'm thinking about it, let me point out again, the number in the sample is 6. So the ends are here, okay? That's where that 6 came from. All right, so my recommendation, if you want to get this right more often than not, okay, the best thing for you to do is to do the top, write it down. Do this piece, write it down. Do this piece, write it down, and then take the top divided by the square root of the first one times the second one. Okay, so let me show you again with a highlighter here. So you're going to do the whole top right here, and that would be this piece. Then you're going to do this half right here, that will give you this number. Let me get one more highlighter color here. Then you're going to do this piece. Oops, that's the same color as what I used before. Let me try again, because I don't want this to be confusing. Let's do this bright blue. Then you're going to do this piece, and that is going to go right there. And you'll do, of course, the square root of that. You should be able to get 0.927. Now, what did you just find? Well, we said we thought the height and the number of stories, it made sense that we're going to have a good correlation here. And our picture shows a good correlation. So 0.927 is going to place that right here on the strong end, which means we do have a good correlation. So we are going to take the time to get, in the next lesson, the line of best fit for this. We'll do the line of best fit. Our correlation is good. We're going to move on. We're going to figure out what that best line is that we can use for predictions. I do want to show you one more. And if you want to freeze the screen and check and make sure you can plug this in correctly, this one is the answer for the final grades, a number of absences. Notice that this one is negative. That's because it's still good. 0.94, that's right here, somewhere in here. That's good. Still strong. It's negative because as one goes up, the other goes down. So if you want to pause the screen and make sure that you can get all your sums in the correct spot and plug it in your calculator, that's what you should get. Here's the intermediate steps. Here's where it's finished. And then you should get negative 0.94. All right, you guys, I'm going to pause the video there, and hopefully we'll have time to do another one for the next lesson.